Question 7, we have to show that the equation this can be written as this. So when we look at this, we can see there's a mixture of sines and coses, but here it's just in terms of sines. So there must be something we can do with this to get rid of it or to change it in terms of sine. And of course there is, because sine squared x plus cos squared x equals 1. Therefore, cos squared x equals 1 minus sine squared x. We can use this identity to eliminate this cos, and hopefully it will look like that. So for part A, we're going to write this down here. So we've got 3 sine squared x plus 7 sine x equals, but instead of writing cos squared x, I'm going to use the identity and write 1 minus sine squared x. Plus subtract the 4. Now, if we look at this, it equals 0, so we'll chuck everything over. We've got 3 sine squareds, plus another one when we take it over will give us 4 sine squared x, plus 7 sine x. We've got 1, subtract 4, which is minus 3, but when we chuck it over, it'll be plus 3, equals 0. And that is exactly what's written there, so 2 nice easy marks done. Hence, that means therefore use what we've just done to solve between 0 and 360 for x, this thing. We're not going to solve this thing, we're going to solve what we've just shown it can be written as, like this. We can only solve trig equations that are in terms of either just sines or coses or tans, not a mixture. So that's why it asked us to do part A. So this here is a quadratic in disguise. Factorise. You've got 4 sine squared x, so just think of it as 4x squared. It could be 2x and 2x, or 4x and 1x. I've done this question before, and I know it's 4 and 1. 2 and 2 just didn't work, so it's 4 sine x and 1 sine x. They multiply to give 4 sine squared x, which is what we want. 1 and 3, if you put the 3 here, you're going to get 12. It's too many. It's 1 here, 3 here. That gives you 3 sine x. That gives you 4, and you want 7, so make them both plus. That means sine x equals, for this bracket, negative 3 over 4. For this one, sine x equals negative 1. We've got a few marks from the 5, but we haven't solved it for x, we've just solved it for sine x. So, x needs to equal, well, we need to draw ourselves a little sine graph. We'll do it in black still. Here. That's a little sketch. You can do cast, but for core 2 it doesn't get very difficult and you can just manage it easily with the graphs. Sine, note here, that's 90, 180. It's 90 degrees for every half peak. I'm only going from 0 to 360 because that's what it wants. We want, when is the, let's do the easy one, sine of x has to be minus 1. So when is it minus 1? I know it ranges between 1 and minus 1. If we chuck this out of the way, minus 1 is when is it here, and you can read it off. It's in the middle of 180 and 360. You know that that's 270. So that's easy. So one solution, x is 270 degrees, and that is between 0 and 360, so that's fine. Next one, we got to do a bit more work. When is the sine of x equal to negative 3/4? Well, negative 3/4 is here-ish. You can see there are two solutions, here and here. But because it's not a nice 1 or minus 1 value, we have to use the calculator to work out one solution for sine x equals negative 3/4, and then work out what the relevant bits are between the range that we want, between 0 and 360. So if you just press shift sine to the negative 1, inverse sine of negative 3/4 or negative 0.75, get an answer on your calculator. Now it's negative 48 point something. 48, get rid of that. 48.59. That's what the calculator will give you, negative 48.59. That's not what you want, that's outside the range, that's around here somewhere. So if we just continue the graph so you can see, every half peak is 90, so that's negative 90. And negative 48.9 has got to be this one here, because it's before negative 90. So that there, if you draw the graph a bit better than I have, this distance here must be the 48.9, this little gap. This gap here must be the 48.59, but we can use that to work out this. Because of the symmetry of the curve, the little gap bit is 48.59. So this bit is 48.59 and this bit is 48.59. So we can work out what these points here and here are by doing the following. X equals, if this is 180 plus the gap, that's 180 plus 48.59. And the other solution for X is 360 minus this gap, minus 48.59. And just use your calculator to work those out. So that is 228.59, and this one I think is 311.41. You see, 311.41. There you go. So there's one here, highlighter. That's one solution, 311.41, 228.59, and don't forget the easy solution here. Try and make them really clear to the examiner by writing them at the end, underlined, because there's a lot of numbers for them to look at. Oh, how did I do that? But these three are your ones that you want. It does say, given your answer to one decimal place where appropriate, so round those to one decimal place, 311.4 and 228.6. I've forgotten, I can't be bothered to get my pen and fix it, but you need to do that. 5 marks, lovely.